Hi everyone, am I audible? Others, can you type in yes? Okay. Great. Good morning, everyone. Welcome to the third class. So we'll continue from where we left off. Okay. Can everyone let me know? Like, did you guys practice some things, revise some things yesterday after the class? Can you brief? If how many of you? Okay, 3 questions. Great. Others? Could you do any practice, any revision? Okay, great. It's 2 questions. No worries, no worries. It like practice takes time, right? So even if it's 2 questions, it's good. First day, okay, no worries, Dheeraj. You'll have the weekend to revise certain stuff. Then 3 basic questions. Okay, don't no worries. Yeah, that's great, Akshay. Actually, okay. So anyone, will there be classes on weekends? Most probably no on Christmas. Like generally, it will be there on Saturdays, other Saturdays, but not on Christmas and not on Sunday also. So you'll have 2 days break to like revise in a good way, complete recursion and backtracking. So I'll also share like the resources and everything so that you are up to like trend with it. And we'll be starting trees next week, so you should be very good with recursion before we start trees. Great. Anything else? uh Anyone else who is facing, how many of you are facing a lot of issues in recursion backtracking? Whenever I see a new problem, my brain stops working. Okay, that happens. So for that, first do brute force, right, Sagar? So then at least it will think of brute force. Then you think the next step, that okay, this is the brute force, this is the pattern that is coming from brute force. How should I optimize it? Okay. Others, how many of you face like problems with recursion in general, like finding it difficult? Can I get a yes? Okay, many people do. No worries, no worries. So it's just a matter of practice, right? Don't just run from it. That would be my advice. Don't just run from it. And today what we are going to do, we are going to take some problems and try to solve them together on recursion topic. And I'll also introduce a little bit of backtracking, which you can study more about, right? Cool. So let's do the pyramid question from tomorrow. And yeah, I'll discuss that, Satish. Don't worry about that. So let's take up the pyramid question first from tomorrow. So I'll repeat the question. So let's say there is a pyramid of glasses, right? Like this. So first row has 1 glass, second row has 2 glasses, 3, 4, and 5, and so on. So there are n, you can say, rows of glasses, right? And what we were doing is we were pouring X liter of liquid at the top, right? And we said every glass has 1 liter capacity. So I said, let's take X equal to 5 for now. So what will happen? This glass will become full. How many liters are left after this glass becomes full? 4. Now what will happen to those 4 is they will pour down equally on both sides. So 2 liter will pour down here, 2 liter will pour down here. Okay, into these 2 glasses. Then this one also will fill completely. How much is left again after this one fills completely out of the 2 liter? So 2 minus 1, which is 1. 1 is left. So half will flow on both sides. So 0.5 liter and 0.5 liter will flow here. Similarly here, this will get full. Half will flow here. Half will flow into this glass. So at the end of 5 liter, these three will be full. This will also become full because half plus half is 1. This one will remain half and this one will remain half. So if you pour X liter at the top with n rows of glasses, you have to tell how many glass will be full at the end. So for n equal to 4 and X equal to 5, the answer is there will be 4 glasses that are filled. Is the question clear to everyone? Yes or no? Some of you were not there in the end, so I have repeated it. But is the question making sense to everyone? Anyone who is unclear with the question, how the question is working? Just type in a repeat or a no. Okay. I gave this as a trial for homework. Did any of you were able to try this out? N was number of rows. Yeah. N was, the number of rows of glasses. Okay. So if N is 5, there will be one more. Is that okay, Anurag? Yeah. So I gave this as a homework. Any of you who did try this out, try this question out, couldn't solve using recursion. Okay. No worries. Others? Did you try it out? Tried but failed? Okay. Some of you did try. Okay. N minus throw by 2k. Couldn't understand. Couldn't understand how to code or couldn't understand the question itself. How to code. Okay. That makes sense. No worries. It's a difficult question. So first of all, this is again a common pattern in computer science where you have a pyramid. Any of you have seen another question that looks like this pyramid? Any other question that comes to your mind? Yeah, Pascal triangle, right? How many of you have done that problem, Pascal triangle? So we have 1 here, then so everything is so every number is a sum of these two. So 1 plus 1, 2 will come here. Then here you will write 2 plus 1, 3. Here also you will write 2 plus 1, 3. And borders will be 1 and so on. So a similar pattern also builds in Pascal triangle. And there are many more problems that are built on the same pattern wherever you see a pyramid like this. Okay. So what is the first step that you do? Just try to number each glass. So how will I number each glass? This glass is present in the first row and it is the first glass, right? So I can number it like 1, 1. Does that make sense? How we are numbering it? Let's look at this one. This is in the second row and the first glass. So 2, 1. Second row, second glass, 2, 2. Similarly, this will be 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. Is this clear to everyone? How we are numbering it? Yes or no? So in a way, what we have done is we have converted this into sort of like a matrix, but half of the matrix. So look at this. This is 1, 1. So if I draw a 4 cross 4 matrix, 1, 2, 3, 4. This glass is actually present here. This is 2, 1, 2, 2. This is 3, 1, 3, 2, 3, 3. And 4, 1, 4, 2, 4, 3, 4, 4. So a matrix lower half is what is formed. Can you all see that? So again, I'm saying this is a common pattern. So don't need to be no need to get scared of this. This is a pattern in computer science. Like many of the questions are solved by this. That what you do is basically you are pushing this whole structure and making it aligned to the left side. Like if I push all of these glasses and make it aligned on the left side, This is what will happen. Yes or no? The first one will go here, second two will shift here, third will shift here, fourth will shift here. So this becomes similar we do with Pascal triangle. We just push it and they all become like this. Okay, that helps us at least visualize what is happening. In this case, we don't have any numbering. So how do we even point out what glass is this, what glass is this, and so on? Okay, so that is why we have come up with this. Now carefully look. If a glass is I comma j, whatever overflows to which two glasses is the liquid going to flow to? So try to make some observations and see for yourself. If a glass I comma j overflows, where will the liquid overflow to? Which two glasses? Can I number them? Which two glasses will my liquid go to? From I comma j. Right. So let's look at this. From first glass, it is flowing to next rows, first and second glass. Yes or no? From first rows, first glass, it is flowing to second rows, first and second glass. From second rows, first glass, it flows to third rows, first and second glass. Similarly, from second, it flows to second and third. So can I say from jth glass of any row, it flows to j and j plus 1 glass of the next row. So I can say I plus 1 comma j and I plus 1 comma j plus 1. Yes or no? I'll repeat what I just said. From any row's first glass, the liquid will flow to first and second. From second, it will flow to second and third. From third, it will flow to third and fourth. From fourth, it will flow to fourth and fifth. So from any j, it flows to j and j plus 1 and of the next row. Is this expression making sense? That from I comma j, whatever overflows goes to I plus 1j and I plus 1j plus 1. Okay, now we have a very simple recursion, right? What we will do, we'll first see if the glass is already full, whatever liquid comes, we'll just make it overflow on both sides. If the glass is not full, first we'll try to fill it. And if it still overflows, we'll again push the liquid on both the sides. So let's try to write a quick code for this. Okay, how do we represent a matrix? Like, how many of you have played with 2D arrays? How can we make such a, does anyone know how to, does everyone know how we can create one with all zeros? Yes or no? Okay, cool. So in whatever language you are doing, like for example, if it's Python, it will be list of list. In C++, I'll be using vector of vector. In Java, it will be a list of list again. So whichever language you're coding in, or array list of array list, whichever language you're coding in, I hope you will be able to make this zero matrix. Okay, what should be the type? What should be the type of this? How I plus 1? Are you talking about this? Or J? Are you talking about I or J? Someone asked a question, how I plus 1. So I'll repeat both of them. I plus 1 because from any row, the liquid is going to flow to the next row. So obviously, I will be plus 1. Right? Does that make sense? So what is I? Just the row number, right? So if any glass in third row overflows, the liquid flows to fourth row. Yes or no? So, and why J is different? Sure, I'll repeat that also. So I said, if I look at the first glass of any row, when it overflows, the liquid goes to first and second glass. Can you see that? Half to the first, half to the second. Then from any row's second glass, it will flow to half to the second, half to the third. From third, it will flow to third and fourth. From fourth, it will flow to fourth and fifth. So from any row's jth glass, half liquid goes to J only in the next row, and half goes to j plus 1 in the next row. That is why we have written this, that half will flow here, half will flow there. Is that okay? Just draw the diagram and you'll be able to see it much better. Okay. So as I was saying, what should be the type of this matrix? Some of you said int, and that is the wrong answer because we are doing half, right? What happens when I do 1 by 2 in integer? Zero, right? 1 by 2 is 0 in integer. So I'll need to make a double, that is a float or a doubles matrix. Is everyone clear with it? Why do we need a double and why we can't use int? Okay. Okay, so now I think we have everything. Let's just try to code this one out. So I will say I have a vector of. Again, I'm saying list of list if you are in Java, or a normal list of list, like you can create it in Python. Your glasses. And it will be of sizes like, so n rows into n columns I'll make, n into n. I'm not writing the complete syntax. Again, it's a huge syntax like n comma vector int n0 and all that stuff, right? But we don't need that. Our pour on an exponential power of 12 liter every second. I don't know. So even if it was like, so the question I think had some time thing in it, that's equivalent to x liter, right? Like if it's saying for x seconds, I think in every second there was 1 liter flowing. So at the end of the day, it's just x liter flowing from the top. To use an integer. Oh, you are saying that we'll multiply it with 2 to the power 12. We can do that, but why to complicate, right? I think this should be sufficient. Yeah, but we can do that. What you are saying, we can do that. Yeah. So at this, as I said, I'm not writing the complete syntax here of like n vector n0 and all that stuff. So you can complete it, like you know it, right? So what I'll do is from main, I'll say pour into 1 comma 1 your x liter. Does this make sense? What is this vector? As I said, it's just a way of representing a 2D matrix. You will see that I'll still be using glasses ij. So if you're using array list, use array list. If you're using normal list of Python, use that. But any which ways, my basic idea is classes of ij should tell me ith rows jth class, right? That is the idea here. Is that okay? If you want int array SSA, that also you can do, like your wish, basically. So yeah, pour to first class x liters. Does this make sense? Pour 1x. Pour into first class x liters. Okay. Now let's write the pour function. Int I, int j, and your int x. Sorry, double x. Why double? Because again, it can be fractional. Okay. Let's look at termination. When to stop? When do we not need to maybe still keep on going? X is less than equal to, not necessarily. What if the glass is already full? Then we would need to still outpour it, right? X becomes 0. Okay, let's not depend first on X. Let's see how we will handle hex. What did I say? I said that if the current glass is full, I'll just pour it on both sides. If the current glass is not full, I'll add to it. And if something overflows, then only I'll call on both sides. So by this logic, X might be automatically handled, and that's not something that you need to look at. You need to look at I and j. If your row number becomes greater than n, that means there is no glass there. It's just flowing into nothingness. and you need to stop. So I'll write if I has become greater than n, simply return. Does this make sense to everyone? My termination? Repeat? Sure, I'll repeat it. So what I'm saying is we had n rows of glasses, right? First row, second row, up to n row. Yes or no? So if while outpouring, let's say this glass also fills, let's say we are pouring some 10 to the power 18 liter, a lot of water, right? So most likely this will also fill and we'll try to overflow from here. Yes or no? Do you agree with this? If it's a huge number, even the last glasses will overflow. So do I need to handle this overflowed water on these? Like this is the bottommost glass, right? So basically if I reach ever beyond the bottommost row, I need to stop. So that is what I have written. If your I has become greater than n, return. Some people are saying greater than equal to. What do you think? It's greater than or greater than equal to? Right, not equal to. We have started with 1. If we would have started with 0th row, then it would have been greater than equal to. Right. Okay. Cool. What to do next? What to do next? I said first we'll check if the glass is already full. So if my classes of ij is already 1, okay. Now, one good point here. How do we compare floats? I'm just doing this because these are fundamentals, but still some people are not very clear with these things. So if I compare two floats, let's say 2.0 equal to x and x also has 2.0. Is this the right way, first of all? What do you think? Comparing two floats like this. Is this the right way or not? Most of you are saying yes, which is the most obvious answer. But the problem is that with doubles or floats, there are precision issues. So as an example, if I have stored x equal to 2.139, it might on the back end be storing 2.138999999. Am I making sense? Because it just stores it like a division, that this divided by something else. So when you say x equal to 2.139, it might be false even though you have just put x equal to 2.139, because on the back end it might be storing it like this. First of all, if this is making sense, because computer just understand 1 and 0, right? It does not store it like 2.139. It is converting it into binary and then storing it. Now that conversion and reconversion might create some precision issues. Okay. So basically what you do is you say, whenever you want to compare floats, you say if x minus 2.139 absolute value, like absolute difference between them is very, very small. So is smaller than 0.00001 or a very small value. So if that difference is very less, then you can say they are almost equal. Am I making sense with this? How do you compare floats? So you check the two floats that you want to compare, you check their absolute difference. And if that difference is significantly small, right? So 10 to the power minus 10, 10 to the power minus 5, 10 to the power minus 7, whatever parameter you want to take, then you say that they are equal actually. Okay. Here we don't need to worry about it because we are just storing 1. So we'll be going to compare greater than equal to 1. So if this glass is already full, that is its value is already greater than equal to 1, what to do? Help me out. If this glass was already full, where we are pouring more water, X, what to do? Everything half will flow down, right? Can you repeat? Sure, I'll repeat it. Did you understand this part? No. This was just how to compare floats, right? For equality, when we compare floats for equality, what happens is, if we have stored X equal to this, it might not be stored like this in a computer. It is stored like binary. So when we convert to binary and then convert back, there might be certain precision issues, like 139 might be stored as 138999, which is almost 139. Was this clear? That how some precision might be lost when we convert it to binary and convert it back? Vaibhav? Because computer does not understand 2, it just understands 1 and 0, which is binary, right? Okay, so because of this, we don't directly do X equal to 2.139. That is considered like a bad practice. What we check is absolute difference between the two floats we want to compare. So let's say we want to compare an X and a Y, and we want to check if they are equal. So we'll write absolute of X minus Y is smaller than a very small number, because that will make sure that if they are very close, then only this condition will be true. Does that make sense? How do you choose the small value? Depends upon your application. For example, if your answer needs to be within precision of 10 to the power minus 5, then you will write 10 to the power minus 6 or minus 7 here. Am I making sense? Right? So it depends upon what kind of precision you want to provide in your application. Okay. Close is different than equal. It is, but in language of doubles, it's almost the same. First of all, if this is clear to everyone, then I'll move on here. This is clear to everyone. This is how we compare floats. Now I said we don't need this because we are actually comparing greater than equal to, which is perfectly okay to do. So if your glass is greater than equal to 1, like basically either it's full or it's overflown previously only, then what to do? So this is the condition, right? Then what to do? Half will flow on one side, half will flow on the other side. So help me out. What should I write? Write the recursive part here. What should I write? Pour of. You guys completed this time. What should I write? Pour of. Slightly wrong, Satish. Slightly wrong. Can you see why you are slightly wrong? Right. Not n double divide, because double divide is integer divide, right? But yeah. Is everyone understanding this case? Okay, many of you have given the answer now. Now I'm okay with it. Right. So if this glass is already full, like, so for example, if you look at this glass, first, let's say it was recursed via this path, then it got recursed via some other path. So if in one of the previous path only this is filled, then I just need to take whatever is now thrown at me and send it across on both sides. So that is what I'm doing here. If the current glass is already full, then just pour half on the, sorry, I plus 1j. N by 2 and pour other half on other side. Is this making sense to everyone? X by 2 0. Otherwise, data type isn't same. Sorry, I did not get that. Why is data type not same? Achha, you are saying you should use 2.0 here. Are you saying that? Yeah, that's okay. That's okay. So in general, if you are dividing a double by integer, I think it remains double. but you are right. It can depend upon compiler to compiler, right? So safe is to write n by 2.0. It can depend upon compiler to compiler. We should not assume that. So we should write n by 2.0 here. Okay. Is everyone clear with this first part of recursion? So if the glass was already full, we will just take whatever was thrown at us, put it on half and throw it on both the sides. Now, what if it was not full? First, we will fill it. Yes or no? So what we will say? We will say current glass, first you become full. Ij plus equal to x. Right? No? Okay. Why no? Satish, you want me to repeat any part of it? Okay, cool. I'll repeat it. This part you did not understand. Should I repeat this part? How many of you want me to repeat this part? First part? Okay, 2, 3, last one. Sure. So what I'm saying is, first of all, let's take this case only. Okay. I'll take an example. I think that might be better. So let's say X is 7 liter here. Okay. I'm pouring 7 liter from the top. What will happen? This will be full. And 3 will flow on both the sides. Yes or no? Do you agree with this? If I'm pouring 7 liter to the top, this gets full. 3 is flown on both the sides. Others, those who had doubt? Yeah, that's X. X is the amount of liter that you are putting. N I have assumed is global. That is global. That you don't need to worry about. Okay. So 3 flows on both the sides. Now they both get full. What happens? 1 flows on both the sides. Yes or no? Everyone? 7 was poured here. This guy got full. 6 was left. 3 on both sides. Now this guy, 3 was poured into it. It got full. Then how much is left? How much is left and how much will be poured on both the sides? 2 is left and 1 will be poured on both the sides. Similarly here also, we are pouring 3. It will get full. So 2 is left and 1 will be poured on both the sides. Yes or no? Can everyone understand this much? So 7 was poured up, 3 on both sides. Then they got full, 1 on both sides. Okay. Now, if we look at this particular glass, if we are doing recursion wise, first left half will be evaluated. So can I say this will get full when this one flows into it? The left side's one flow into it? Yes or no? Remember recursion. First you go on the left and completely explore it, right? We'll do that, but let me complete the code first, right? Then only we can try run. I'm just trying to explain the example. So what I'm saying is, in recursion, what happens? When you are recursing for the left and for the right, saying that 3 will first flow here, then 3 will flow here. First, this half is evaluated. So when 1 flows on the right, this guy is already full. Can everyone see that? Yes or no? When this one flows, this will get full. Now, when the one from the right glass comes here, that is the case that I'm talking about here. So if this glass is already full, that is, if the current glass already has greater than equal to 1, then what do? This one that you got extra, you just put half on both the sides. So that is what I'm doing. Just pour half on both the sides. Is this case clear to everyone? Yes or no? N by 2, it should be x by 2. Oh, yes. Is it okay now? Okay, cool. And we should also actually return here because this case is over. Else. Okay, now we'll go to the else part. That is, if this glass was not already full. If this glass was not already full, first, whatever liquid I'm getting, I'll just put it into the glass. So I have just written that current glass, you add whatever amount you have got into the glass. Now, is this making sense? So this is just adding whatever you have got into the glass, nothing more than that. Then you will see what overflows. Okay. Now if the glass has become full, that is same thing. Now if the glass has become full, what should I do? I should pour the overflown part on both the sides. So help me out. What should my recursion be? So glass was not full. I pour extra water into it. Exactly. So whatever was overflown is, whatever the value is, -1, that is the one that will overflow. And half of it you will pour on both the sides. So I'll say pour I plus 1 j glasses of ij -1 by 2. And similarly pour I plus 1 j plus 1 and the same thing. Why glasses of ij -1? That one will remain in that glass, right? That will not overflow. So what will overflow? Glasses of ij -1. Now whatever overflows, you put half on both the sides. Is this part making sense? Yes or no? So if it was already full, just take whatever you are getting, overflow. Otherwise, first make this glass full. Now whatever is left, that is whatever you want to overflow, just make that happen. Some people are saying no. Okay, which part? Which part do you want me to repeat? Please explain this part again. Sure. This one. Okay. So till now we are in what case? We are in the case, for example, let's say there is a glass which has half liter in it. And now I'm pouring 2 more liters into it. Is that okay? That part is not visible. So I will write it here. Right? This glass is half already and I'm pouring 2 more liters into it. So what will happen? First, what I'm doing is I'm saying now this glass has 2.5 liter total into it, which is what I'm doing here. It was half, I added 2 to it, so it becomes 2.5. Is that okay? What is that step? Now I'm saying if now it has overflown, which it has, the remaining, which is after subtracting 1, the remaining 1.5, half will flow on both the sides. So what is remaining is 1.5. That is what I've written, glasses of ij -1. And half of it will flow on the both sides. So 0.75 on this side and 0.75 on this side. Am I making sense now? So because of this 2.5, it got overflown. So I'll subtract 1, which will remain here. And then remaining 1.5 will go on both the sides. Why both are same? Both are same, but they are actually different. Why? This is after adding the current water into it. So first we are checking if it's already full. If it's already full, just throw the water on both the sides. If it's not full, then plus first add to it. Now if it has overflown, throw it on both the sides. Is that clear, everyone? On how to solve it? Okay. So this question took a lot of time. So let's move on from this. Any doubts in this question? I'll happily take that up. Otherwise, we'll move on and actually discuss when to use recursion and try to solve certain problems which are actually only solvable by recursion. So any doubts so far, let me know. I will remove these classes at least. Code is there, so you can ask for doubt from there. Anyone who wants me to dry run some part of it? Some small case? So I told, right, Setul, they are not actually the same. This class ij was previous value. This class ij is after adding x. So someone is asking, do I need a return here? So I said, so you tell me, do you need return at the end? No, right? Because it's automatically returned. Rohit. So when the function ends, it automatically returns, right? So you don't need to worry that much about it. Okay. Where are we updating? Excellent. Like there are a lot of questions. How do we come to know how many classes become full? What do you think, Mayur? How can we get to know that? No, we are not returning that value. We can just count, right? We can iterate on this classes nn and see how many are greater than equal to 1. In the main, I can simply run a for loop for I equal to 0 less than n, j less than 0 less than n, see if it's greater than equal to 1, just count it, right? Simple counting problem. Can you do that? Yep. Yes. Just running a 2D, like 2 loops to count it. That's it. Above case is also handled in second case. No, that will create a problem. Tanush, just think about it a little bit. But that will actually create a problem. Why? Because if the same glass gets filled multiple times, you will always be subtracting one and then throwing the same water on both sides. Just think about it and try to fill the same full glass multiple times and see what will happen. What you are saying will not actually be working. Where are we updating values of x after pouring? We are passing the value of x, right? So what is value of x? That is the amount of water flowing. So at top, if 5 liter flowed, we are just passing half on both sides, right? So automatically being updated. Dry run the whole code, taking some input. Sure, I'll do that. Double nested loop. Yeah. So let's take our case only, n equal to 4 and x was 5, right? So I have my 4 cross 4 matrix. Relevant data is only here. Oh. Do you agree? Like this much? Not visible. This part is not visible. Is it visible to everyone? It should be visible. Have you zoomed or something? Just try to contract it off. Okay. So I was saying, let's take a case n equal to 4, x equal to 5. So what do? We call 1, 1. Let me number it. 1, 2, 3, 4. 1, 2, 3, 4. So I'm calling 1, 1 with 5. So 1, 1 with 5. Let's look at this. What will happen? Is current class full? What do you think? Are we going in the first case? Is glasses of 1, 1 greater than equal to 1? No. So we'll go in the next case, which is add 5 liter here. And then whatever is left, if it is overflown, will the second condition be true now after updating? Yes, right? Now it has overflown. So you will pour to I plus 1j and I plus 1j plus 1 glasses minus 1 by 2. What is glasses minus 1 by 2? Can you calculate? Glasses of ij, which is glasses of 0, 0, minus 1 by 2. How much it is? How much is it? Okay. So we are calling two functions. Remember our recursion tree. We are calling two functions. I plus 1j, that is 2, 1 with 2. And we are calling 2, 2 with 2. Is this clear to everyone? In the last case, there has only been one case so far, right? So see how it will happen. You didn't make it 1. Why? How it is becoming 1? Where is it becoming 1? After pouring. So we are pouring 5 liter at the top. So 1, 1, 5. I go here, this condition is not true. I go here, this condition is not true. I'll directly go here and say current plus equal to 5. That is what I've done, 0 updated to 5. Do you see that? When will it become 1? It will never become 1, right? But after pouring, why to make it 1? It can remain 5, right? Still it's greater than equal to 1. No? Oh, okay. Yeah. So we have called this and we have called this. So let's expand this first. 2, 1, 2. So help me out. Is glasses of 2, 1 full? Is glasses of 2, 1 full? Everyone? No? So what I'll do, I'll add whatever is it to it. So glasses of 2, 1 plus equal to 2. Then now has it overflown? It has, right? So what will the two calls be? I will call 3, 1 with 0.5 and 3, 2 with 0.5. Yes or no? Oh, I think yeah, equal nahi aayega yahan pe. Right. There will not be an equal here. Like only if it has overflown, then only you will call, not equal. If it's equal, it's just full. Right? Okay. I hope this is making sense to everyone. Okay. Let's evaluate this then. 3, 1.5. Is it full? 3, 1. Is it full? No. I'll go here. I'll add 0.5 here. Now, is it overflown? No, right? So we'll stop here. Like neither this got true, neither this got true. We'll simply return. Is this making sense to everyone? Now this will run 3, 2. You add 0.5 here and then also simply return. Now I think you'll be able to continue, right? Will you all be able to continue with the dry run? Just try on your own. And similarly, the right side will evaluate, right? We'll add 2 here and then 0.5, 0.5, 0.5 will flow here. This will become 1. Finally, you can count. So we have 1, 2, 3, 4. 4 glasses having greater than 1 value. Okay, great. So let's move on from this question now. And let's talk about the next important thing, that is iteration versus recursion, when to use which. So till now, whatever we have done has been using recursion, but it can also be done using iteration. So as an example, here also, doing iteration is simple. If I want to know how much water will come here, I can look at how much will come from this side and how much will come from this side. Can you see that? Right now I was saying, okay, I have this much and I'll flow it to both the sides. But I can do opposite also. I can just look at a cell and see how much water will flow from this side, how much water will flow from this side. And still my solution might be, there might be a solution with iteration also, basically, is what I'm trying to say. Okay. So, but when can we only rely on recursion? That is the question. So for that, I will explain a concept called element of choice. So whenever we have a choice for every element, so choice for every element is a better word actually. That is when you go for recursion. So I'll take a few examples and explain what do I mean by choice for every element. So let me take a very simple case. Let's say we are given an n cross m matrix. Let's take a small matrix. We are at 0, 0. We have to reach nm. We can go right or we can go down, and we have to find number of ways. Okay. So a simple problem which says you are given a matrix, you are here, you want to reach here, and you have to find the number of ways to do so. So as an example, one way could be if I go like this. Second way could be if I go like, I go down here from here, down from here, down from here, and then like this. Third way could be I go like this. Is the question making sense? What the question is asking you to do? N cross m matrix, you are here, you want to reach here, and you have to find the number of different paths with which you can reach here. Okay. So now, what is element of choice here? You are on any particular cell, you have options with you. And what are those options? Either you can take a right turn in the path, or you can take a down turn basically to reach to the next element. Going right or going down. These becomes your choice at every position. Am I making sense? Yes or no? What do I mean by element of choice? So at every position, you have a choice. Either you do one thing or you do another thing. Here are choices. Either I'll go right or I'll go down. So whenever I have at every step a choice to make, there to explore all the possible choices, I can use recursion. I'll take a few more examples and then it will become super clear. But is the idea making sense? So whenever there are choices and you want to explore all the choices to find the best choice or to find total choices, stuff like that, you go for recursion. Yes, no, repeat. Might seem abstract, but you will slowly, when you do more practice, you'll be able to realize it. Okay. Let's take one more example. How many of you have played a game called Sudoku? Have you played it? Sudoku? How many of you have not? You can type in a no if you have not. You have not? Okay. Others? Anyone who has not? Okay, many people have not. Great. So it's a simple board game. I'll make a small version of it. There are certain boxes, 9 of them. You want to place numbers in each of the cells so that a row, a column, or a box don't have the same number repeated, right? So as an example, if you put 9 here, you can't put 9 here, here, in any of this box, or in the same row, or in the same column. These are the basic rules of Sudoku. Okay. But what I want to point out from here is, again, you have choice. At each place, you can place a number from 1 to 9. And you can explore all the choices. If I put 1 here, will I be able to solve the Sudoku? If I put 2 here, will I be able to solve the Sudoku? And so on. Even if we extend it to chess, right? There also you will have choices. Should I play this pawn? Should I play this knight? Should I play this rook? What should I do? So there are choices. So if you want to explore all the choices, that's how chess engines work, then that can only be done by recursion, that you make a move, check how it will play in the whole system, and then take it back, try to play another move and see if that is better. Am I making sense? Yes or no? That where do we go for recursion? Wherever we have different choices and we want to explore the choices to get our best solution or to get our best number of solutions. Okay. So I'll take one more problem and we'll try to solve it using recursion and see how that becomes a problem with choice. So this problem says, let's say we have a keypad phone. How many of you have seen a keypad phone? So there is a phone which is like this. So we have 2 here, 3 here, 4 here, 5, 6, 7. Sorry. 1, 2, 3. Let me. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. There is a phone like this. There used to be a keypad, right? And there used to be some letters below it, like A, B, C. Here it used to be D, E, F, G, H, I, J, K, L, M, N, O. Here it used to be P, Q, R, S, T, U, V, W, X, Y, Z, space. And here used to be some symbols. Have you seen this kind of phone? Like there used to be previous phones before smartphone that used to be like this, right? So the question says basically that, yeah, Nokia 1209, yeah. So question basically says, let's say you are given a digit string. So let's say the digit string is 26. Now what you can do is you can try to replace every letter in it with every digit in it with some letter written on that particular keypad. So for example, 2 I can replace with A, B, or C. 6 I can replace with M, N, and O. And what you need to do is you need to print all the possible words that you can form. So as an example, if I replace this with A and this with M, I'll get AM. If I replace this with B and replace this with O, I'll get BO. And so on and so forth. There will be a lot of different possibilities. Can you all see that? Yes or no? Can you calculate how many possibilities will be there in case of 26? Nine, right? Yeah. So 3 options for this, 3 options for this, 3 into 3, 9. There will be AM, AN, AO, BM, BN, BO, CM, CN, C. So 9 options, right? If I write another 7 here, can you calculate the number of options quickly? No. Carefully look. 36. 36 is the right answer because 3 into 3 into 4. There are 4 here, right? So yeah, 36 is the answer. Cool. So basically this is your question. Given a digit string, given this keypad, you want to print all the possible options. Okay. So now here, if you look at, there is a clear choice for each digit. What is the clear choice that you are making? Every digit you can replace with either of these. Every digit here you can replace with either of these. So this is a clear indication that this question can be explored to be done via recursion. Does this make sense? Because we have choices for each element. This can be done via recursion. Yes or no? Okay. So let's think how we'll go about it. How can we go about this particular problem? What should be our steps? Anyone? Any ideas? Create a matrix? No. Think. We have to do what? We have to build a string, right? So how can we go about building the string? We have to build different strings, right? So what should be the idea? Use stack. No. So whenever we have choices, we explore those choices, right? That's the plain point of recursion. So what do? We want to build a string replacing each character. We'll go character by character on it. So let's say we are currently at exploring for 0th index with an empty string. So what I'll do is I'll either replace 0th index by A or by B or by C. So I'll say go to first index, explore it using A. So basically I'm doing a plus A here, or change it to B or change it to C. Okay, let's take a moment and try to understand this like in a good way. So what I'm trying to say is, what do I need to do to get a string out of it? I need to replace 0th digit by a character, first digit also by a character, and second digit also by a character. Do you agree with this? Yes or no? I have to replace each of them by one character from their lists. So what I'll do is I'll go index by index. First, I will replace for 0 all the options and explore them. Then in each of those options, I'll say replace 1 with all the options and then replace 2 with all these options. So first I'm starting with 0 and I said, let me replace 0th digit by A and explore that side. So what do? I put an A here and say, now, okay, go on and explore for 1 and 2. Then I say, okay, now I'll do with B. So I put a B here and said, explore for 1 and forward. I put a C here and said, explore for 1 and forward. Is that part of recursion tree making sense? So making a decision for 0, making a decision for the first character, putting there A, B, or C, and then saying, okay, now we'll explore for the remaining characters, which are index 1 and 2. I'll do one more step, then it might be much more cleaner. So from here, what I'll do, now I have to make a decision for first character. What are my options? M, N, and O. So I'll say add M first, go to 2. Now you have AM with you. Or add N, go to 2, you have AN with you. Or add O, go to 2, you have AO with you. So making a decision for current index by trying all the options, recursing for each option, and then saying, okay, now explore for the next index. Is the idea making sense? Yes or no? Everyone? Anyone who wants me to repeat this? Repeat. Sure, I'll repeat it. Okay. So again, what I'm saying. So in totality, what do I have to do? In totality, what I have to do is, let's say I'm given 26. I want to replace this with either A, B, or C. So I have to make a decision. Should I replace it with A? Should I replace it with B? Should I replace it with C? Right? A decision for the 0th index. So I'm saying I start with making a decision for 0th index. Right? So from main, I will say, start with making a decision for 0th index. Right now, your string is empty with you. So what I do, I make a decision for 0th index. I say I'll put A first. So I put A there and then ask a friend of mine to say, make a decision for 1 index. What do you want to put there? Then I put a B here and ask one of my friend that, okay, now you make a decision for 1. What do you want to put after B? Similarly, I put a C here and ask another friend and say, now you make a decision for 1 and going forward. Am I making sense? So for this current index, my function will make a decision. It will try to put A, try to put B, try to put C. Now it has 3 different cases, which it will hand over to recursive calls, that now you make decision for the remaining character, which is 6, right? If this was even forward, my friends would have made the decision for 6 made cases and passed on those to another recursive call to make a decision for 7, and finally to make a decision for 9, and so on. Am I making sense what I'm trying to do here? So for current index, the current function will make a decision and pass it on to the next ones to do it. How can it be determined whether A, B, C? One second. How can we determine whether A, B, C will only assign for 2 and other numbers? That we have to make sure, right? That we have to make sure while writing code. But for logic, that is not important. So first of all, separate logic and code. Yeah, some people have suggested map. So map could be a way, list could be a way. There will be different ways. But logically, this is what I have to do, right? Then we'll see how to write a code for this. Okay. Yeah. Similarly, from here, you will add M, you will add N, you will add O. And you will go to 2BM, 2BN, 2BO. Similarly, you can complete this. Okay. Should I continue from here? Like assuming this 26 was only my number. What should I do after this? Stop. This is one of my answer. This is one of my answer, right? AM is one of my answer. So I will basically store it somewhere and then say, okay, this part is done. Go back. Yes or no? Okay. So let's do one thing. Let's try to code this much out and see if we are able to get somewhere. So first of all, I need to somewhere store the information that for 2, I want to replace it with ABC. For 3, I want to replace it with DEF, and so on. So how do I store that information? I need this information, right? For which digit, what characters I can replace it with. Right. Either it can be a map. Those of you who know map can do it with that. Those of you who don't know map, we can also store it in a simple array. So I'll have a simple array. Let me call it digit map only because we are having a map. So for 0, there is nothing. For 1 also, there is nothing. For 2, there is ABC. For 3, there is DEF. For 4, there is GHI, JKL, MNO, PQRS, TUV, and WXYZ. So how will this list help us? If I do digit map of 2, I will get ABC. And now I can iterate on it and know these are the things that I can put in place of 2. Yes or no? Okay, this part is not visible. That's okay. I've just written it like digit map. I've just named it. That's just digit map. Okay. But the important part is this. If I do digit map of 2, I will get ABC. That is, it will tell me these are the things that you can place instead of 2. Is this making sense? Yes or no? Okay. Let's look at our recursion. What all do I need? I need a string and I need an index. So let's build on top of that. I need 2 things. We'll see if we need more things later on. But right now I know I need an answer string that I'll build moving forward, and I need an index. So I'll build a void function. This part is not visible, right? So void find combinations. I need a string, answer, and index. Is this okay? Okay, help me out with termination. When do I need to stop? And what do I need to do when I stop? Look at this and tell me, when do I need to stop first of all? Anyone? So what all do I need? I also have a digit string, which is like 26, right? When there is a string that matches with map, right? When you have made a decision for all the indices, when I've made a decision for 2, I have made a decision for 1, and now I have reached index 2, that is where I need to stop. So if my index has reached digit string dot size, can I say I made a decision for everyone? Just take a look at this and see if this is making sense. For example, we are solving it for 26, right? As soon as I have reached 2, that means I made a decision for 0, I made a decision for 1. Now I am at 2. That is, I have made a decision for every digit of my digit string. Yes or no? No? Repeat. Anyone? So what I'll do, this is my answer. I'll store it. So let's have an answer list as well. So a list of string, which will be your answer list. So I'll say answer list dot push answer and return. So whatever answer I have got so far, I'll put it in my answer list and simply return from here. Is this making sense to everyone? Just type in a repeat. I'll happily repeat this part. It is okay. Again, recall. Yeah, great, great, great. Again, recall what we were doing. We had 26. I said we'll start making decision at index 0, right? Once we make a decision for index 0, I'll call another function asking it to make a decision for index 1. Do you remember this? Everyone? Yes or no? Now, when do we stop? When we make a decision for index 1 also, and this guy calls to make a decision for index 2, which is not there, then I need to stop. That means if I have taken a decision for all the digits in my string, then I need to stop. Do you agree with this? So exactly that is what I have written here. So if while making decision for each index, like index 0, index 1, index, if you reach at index equal to digit dot size, assuming 0 indexing, then you need to stop. Does this make sense? This and this. I'll tell why we are doing this, but does this basic structure make sense? So if while exploring each index, you have made a decision for each one of them, now you have exhausted your string, you need to stop. Plus, when you actually stop, you have made a decision for each of them. So you have your answer at hand, one of the answer at hand. So you'll simply push that into your answer list because that is one of the possible answers. Yes or no? Everyone? Okay, great. If this does not happen, then what do I need to do? I need to make a decision for the current index. So let's do that. So I will say first, the digit at the current index for which I need to make a decision is basically digit string of index. So basically, if my index is 0 at the beginning, I'll be making a decision for digit string of 0, which is 2. If index is 1, I'll be making a decision for digit string of 1, which is 6. So this stores my digit for which I'm making a decision. Does this make sense? What is this step doing? So I've extracted out the digit for which I need to make a decision. Here it would have been 2. Here it would have been 6. Yes or no? Okay. Now I need to know what all can I replace it with, right? Little bit confusing. No, just look at it, what I'm trying to do. So I'm saying this is the index for which I want to make a decision. So index, let's say, is 0. That means right now I'm making a decision for 2. Should I replace it with A? Should I replace it with B? Should I replace it with C? Do you agree with this? So I have extracted out the digit here. I have just taken it out so that I am sure that I'm making a decision for this one. So I've simply done that. I've taken this 2 out and stored it in this digit. Okay. Shouldn't it be digit size -1 equal to index in the first case? Digit size -1. No. So when you are at -1, you still need to make a decision for this last one, right? You have options still. If last one is 6, you can replace it with M, N, and O. You still are not done with your string. Does that make sense? Okay. So we have our digit. Now what we will do? We need to extract out what all can we replace it with. So I will do digit map of digit. Can I do digit map of digit? No. Why? Why do you think I can't do that? Digit is a character. If I do digit map of character, what will happen? How many of you are aware of ASCII values? If I do array of character 0, it basically converts to array of 48. How many of you know this? Why? Because character 0 is essentially 48 in terms of ASCII, right? In most of the language, and I'm not saying in every language. Some languages like Python might say that this is actually 0, so I'll take array of 0. But in most of the languages, if this is an int, it is auto casted to 48. So what I need to do is, generally, I need, like, if there is a digit here, I need to do digit minus character 0. So that is what I'm going to do here. So I will say string to replace, what all can I replace it with? I'll say digit map of digit minus 0. Is this making sense? That minus 0 is just so that it is converted into actual ASCII like of that particular digit. Sorry, actual number of that particular digit. Okay. Now I have this ABC. What I'll do is I'll replace one by one. I'll put A, I'll put B, I'll put C and recurse. So what I'll do is for int I equal to 0, I less than 2 replace dot size, I plus plus, just recurse it for answer plus 2 replace of I and index plus 1. Let me quickly repeat this, what I'm trying to do. So if this was ABC, I am saying I'll go character by character on this. So for an int I equal to 0, I less than string dot size, I plus plus. If I am at A, I will add it to my answer. So it was empty. I added A to my answer. And now call recursion for next index. Is this making sense to everyone? So I'm going over it. Like first I'll go to A, I'll add it, call for the next. I'll put B, call the next. I'll put C, call the next. Okay. Can we do int of digit? Depends from language to language. Which language is able to interpret it, which language is not. This is safest. This works for every language. So in some cases, if you want to convert into it, like in Python, you'll have to do ORD digit minus ORD 0. That's a separate thing. Sure, I'll again explain it. Sadish, can you please also explain drawback of solving this problem using iterations? We can't. You just can't solve this problem using iteration. If there are 10 digits here, you'll have to use 10 loops. If there are 100 digits, you'll have to use 100 loops. That's simply not possible. Okay. Anyways, didn't understand digit map, digit minus 0 part. This one. So I said, if you write array of, actually in Python it might work since I know you code in Python, but if you ever write in any other language array of digit 0, sorry, character 0, it basically means array of 48 because character 0 in ASCII code is 48. Is that okay? So what you do to avoid it is, let's say you want to calculate array of actual digit here. Let's say that's 2. So what you do is you'll do 2 minus 0. So ASCII of 2 minus ASCII of 0. Since they are continuous, when you subtract their ASCIIs, it actually becomes 2 only. Is that okay? Why this for loop? We require this for loop because we want to go character by character on this string. The possible options. Right? For example, if it's 7, I want to try P, try Q, try R, try S. So this 2 replace I tells me the character that I'm trying right now. Okay. Cool. We can also do by digit map IDX. No. What is digit map? This, right? If you do digit map of IDX, when IDX is 0, you'll always take this. When IDX is 1, you'll always take this. You don't want that. You want to know what is the digit here. So if that digit is, let's say 5, you need to look at digit map of 5. Am I making sense? Why those two are different things? IDX is what? IDX is your index of this digit string. You want to look at digit string of IDX. If that is 5, you want to go to digit map of 5, not directly digit map of IDX, right? Yeah. Cool. So this was an interesting and difficult problem, but yeah, code till here, the output is A, B, C, and it will recurse. So now we'll go to index 1 with A, B, or C into again this function. Now it will again get digit at index 1, and it will get what all to replace, right? And then it will again call till we have made a decision for everyone. Okay. Yeah, recursion is tricky, I agree, and it's not even possible to like master it in 2 days, like if you are coming completely from scratch, right? But what I would advise is use next 2 days very, very wisely, uh, and try to make sure that you master it very well in the next coming days. Why in the map first two indices are empty? Yeah, because for 0 and 1 we don't have anything here, right? So our keypad started from 2 for some reason. 2 had ABC, 3 had DEF, and so on. So 0 and 1 did not have anything. Okay, they had space, but they will not be part of your digit string also. So we can ignore them. Is that fine, Sai? Do it very nicely. You have not written your complete name. I can just read your question with the name P. So how much time or question should I give on recursion in one go, considering I have to sit for placements? A lot of time, because see, recursion directly binds to tree, graph, and DP. At least these three that I can directly recall from the top of my mind, even understanding heap and its implementation. So if you want to master those three, then you need to do this like in a very good fashion. Okay. How are you going to add counter variable? There is no required of like, there is no need of counter variable here, right? We just need to push. We are just pushing all the answer in this list. So once we go over this, finally, if we have made decision for everything, we'll just take our answer and put it in the list. AM, AN, one by one. And then we can just use this list to print our answer. Yes, 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 yes. Yes, it works the same. JavaScript has made certain complex things around it. So not in JavaScript per se, but it works same in every other language. Okay, you are into JS. Function stack still remains the same unless you introduce async and await and all that stuff, because in that case it goes into event loop and all that stuff, right? Function call logic is still the same. Only the logic of context, sorry, not context, what is that called? There is something which binds the variables into function. I'm not sure if it's called context only. So that part is slightly different, like the global and local variable concept, because there is variable hoisting and all that stuff. That part is, yeah, closure, right, 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 closure. So because of that closure and closure etc stuff, pass by value, pass by reference are not exactly the same, right? That is the only change, but normal call stack I think remains the same. Okay, like you'll be able to code this still in the same way in JavaScript. No need to do anything different here. Okay, then I'll probably pause here. I think it has been a long and grueling session. I'll be posting a good amount of links for you to go over in the next 2 days. I know it's a Christmas holiday. You can enjoy but also if it's a good time to make sure that you study well, because we'll be starting trees. So though not this kind of heavy recursion will be used, some part of recursion will be used, and so that you don't get confused, you need to be to a certain level in terms of recursion, right? DP will use extensive recursion, so we'll come to that, but we'll cross that bridge when we reach there. So yeah, we'll be starting with trees next, and for that I'll be giving some resources to revise over the weekend. I think everyone got an access to the like did everyone not get an access to the dashboard? Okay, you did not. Did you make an account in proimpadshala.com? I think I stopped that script. Okay, I'll run that script once more today and give you the access. Make sure that your account is same as the one that you used for registering, right? Just ensure that. Okay, cool. I'll give it today. A lot, not recursion, but tree questions are a lot asked. Then related to recursion, there a lot of them are asked, right? And no need to be scared. We have just had 2 sessions, and I admit that some tough questions were taken, right? Takes slow time to build up, so just make sure that you don't give up, right? And just try to give your best there. Okay, Kavish, it might take time, but it will be okay, right? It will, in 3-4 days you will be good at it. Okay, then I'll stop here. I hope you all enjoyed the session. Bye bye. Happy, like, Merry Christmas to everyone. Bye bye.